Hello, Lower Elementary. Today I am going to do a weather experiment. The experiment is called How Windy Is It? So this is actually the same chart that I have uploaded onto Sycamore under the Cultural Studies page, and it tells you exactly what you need. So one of the things that you need is a modified Beaufort Scale chart, and that's what this is right here. It tells you how windy is it, what is the probable miles per hour of the wind, and a lightweight scarf or a handkerchief. And so I have a little scarf here and a piece of paper. So I found this on the kitchen table. This is a picture that Jacqueline just drew today. You need some matches and a candle, and it says a taper candle, but since we are at home and not going to a lot of stores, are not open, and so this is one that hasn't really been used yet, so the wick is close to the top, so it would be able to be caught by the wind. So as you can see around me, behind me, the wind, I'm on my front porch, the wind is blowing. You'll also see how the wind is blowing our flag right here. So I'm excited to try this experiment with you today. Okay, so the first thing that it asks you to do, we are going to see how the wind can move our papers, how it can move our scarf, and wind has been around for so many years to be able to help people explain weather, explain ships and the direction of the ships and the timing of the ships and how ships sail from one place to another. It was how they got from one continent to another when they were sailing, and today it's used for critical energy needs as well. So think about all the wind turbines that help make wind, and it's really great. And of course, you know, we recently just had a tornado, and you might be able to hear some of the chainsaws going on in the background because the tornado went right through my neighborhood. And luckily our house is fine and we are all good, but there's trees down everywhere, and workers out fixing all the lines, the power companies, the internet companies, and tons of chainsaws and just pickup crew that are trying to get our neighborhood back together. So when it's out of control, it can do a lot of damage. The street right behind me had 2 houses fall on it, right on either side of it. Luckily, no one in our whole neighborhood was hurt by anything, but we've had a lot of damage, a lot of cars that were smashed in our neighborhood, and I know where Miss Eleanor lives too. There was a car that was smashed too. A lot of roofs. You know, our neighbor right next door had their shed that flew over and their trampoline that landed on their roof. So wind can be really cool, can be really interesting, but it can be dangerous at some point. So how do we measure wind? Let's talk about that. For nearly 2 centuries, people have referred to a scale that was first developed by a British admiral named Sir Francis Beaufort. So this is called the Beaufort Scale. Scientists have tinkered with it a bit, but the basic idea is the same. An observant scientist can estimate from regular clues the speed of wind. So, and then we can estimate its force. So, what to look for? So I'm going to first start with smoke. So smoke or vapors. If the smoke or vapors go straight up, then we would describe it as calm, and the miles per hour would probably be less than 1, and the force would be 0. So we're going to start with that. So I'm going to put my other props down right here. Here are my matches. So we are going to see if it goes straight up or if it drifts slightly. Nope, and it's breaking. I don't know if y'all saw that. I'm going to blow it out now. Oh, whoa. I didn't even have to blow it out. It blew. So it did not go straight up. So there is quite a little bit of wind out here today. So the miles per hour is definitely more than 1. So if the smoke drifts slightly, which kind of went almost sideways, which was really cool. They would call that light air, and the probable wind miles per hour would be 1 to 3, and the force would be 1. Now, if we're thinking about, the wind goes off and on, it's not constantly blowing. But the next part says, do you feel wind on your face? So right now, I don't. But a minute ago I did, and you can see the leaves behind me. That's why I set up right here. Because in the winds behind me, you can see that really pretty maple that I have behind me. You can see when the leaves blow. So we'll keep our eye on that one. But if it says, if the wind is on your face and the leaves rustle a little bit, that's called a light breeze. And that would probably, wind would be between 3 and 7 miles per hour and about a force of 2. Now, if paper blows around in the wind, or if there's dust or leaves that are moved on the ground, that would be a moderate breeze and 8 to 20 miles per hour and a force of 3 to 5. So I am going to put this down, and I'm going to put it down right behind me, and we're going to just watch it as it goes on our the rest of our video, and see if anything happens, if the wind picks up, because sometimes it can be really, really, really windy, and then it could stop, and then sometimes it can just constantly have a light breeze for the whole time. All right, so here we're getting a little bit of a breeze. See, look at my hair. I wore it down so you could be able to see it and how it can move, and our trees are rustling behind us, so that's about 3 to 7 miles per hour, or force of 2. Now my paper is not moving. You can see that paper down there. It's still not moving yet. So we're gonna keep watching it. All right, now wind moves tree branches. So some branches are much, much, much stronger than others. So I'm gonna show you these branches in the background. Those branches are definitely moving, and those back there are definitely moving. Now there's a difference between a branch and a limb. So the bigger ones are limbs, and the ones that come off of it are branches. So those branches are definitely moving. See my hydrangeas that haven't quite bloomed yet? Those are definitely moving too. I'll put you back up here. All right, so wind moves tree branches, little waves form in lakes or open water. What I'm actually gonna do is, you can see the grass behind me. I'm gonna put my picture right there because I think that my house is blocking the wind from it. Maybe I might catch some more wind if I put it a little farther away. Okay, so if the wind moves tree branches, I say it's a strong breeze, a pretty strong breeze, 25 to 38 miles per hour, probable. Now, if a wind is so strong that it might break off small branches off of trees, or if it's like so hard when you're walking, like maybe a little kid, like a 1-year-old might have a hard time walking, then they call that a gale force wind. So that's something that you hear whenever you're watching a meteorologist and talking about tornadoes or hurricanes, that word gale force wind, which I think is really interesting. So that probable wind is 39 to 54 miles per hour, or a force of 8 to 9. So when you hear gale force winds, that means that something's starting to go. Maybe it's a thunderstorm, maybe it's a tornado, maybe it's the beginning of a hurricane, and you should probably start to seek some shelter. Now, wind can blow down big trees and even buildings and cause major storm surges at sea. That's when we get to the hurricane. So probable wind, 55 to 73 miles per hour, or even more. So the force of that is 10 to 12. Oh, the wind's going again, but it's not really catching my picture right now. I think maybe it's still being blocked by some of my bushes, but you can see if I hold this up, it's constantly swaying. Oh, no, there's my paper. It's starting to go. My paper flew. And it got caught in the monkey grass over here. Let's go catch on it. See, it's gone. It moved. Wow. All right. So that's moving. My flag is really blowing hard there. So let's see what will happen. Sorry about my finger. I'm gonna put you back over here. Let's see what will happen when I light my candle. The wind is actually starting to pick up, as you can see in the trees behind me, which is fun. Sometimes there's no wind at all. Well, there's another truck that's actually coming to pick up more debris from our neighborhood from that tornado. There's constantly. All right, I'm gonna light this candle or see how long I couldn't even light it. The wind was blowing so hard that I could not light my candle. I will try one more time though. I'm gonna light it this way so the wind is not blowing it. And then I'm gonna put it this way. See how long it takes. Well, the wind has slowed down a little bit and I'm kind of shielding it. But if I move it this way, it protects it even more. But if I move it this way, it's flickering hard, isn't it? This is a very strong candle, so it's not quite getting blown out. I wonder how long it would stay. It's still flickering. The match went out immediately, but that wick is a lot stronger than a regular match. So, for this follow-up work to explore wind, one of the things that we could do would be some wind research, hurricane research. You could do some research about tornadoes. You could do your own experiment like I did. So you would get the things that I said, and you would print this off, or you could make your own little Beaufort scale, and just have it as a reference, and even do a wind log. So say you're gonna every day at 10 o'clock you're going to log what the wind is like outside, and do it for a whole week and see what days were more windy, what days were not, and what was the temperature like those days. Does the temperature, the atmosphere, the clouds, the sun, all those things affect the weather. I enjoyed learning more about wind with you guys today, and the thing that I thought was really cool is I didn't realize what would cause it to be a gale force wind when I started learning about this weather experiment, and so it was really fun to learn that with you, and the fact that the scale came from a British admiral whose name was Sir Francis Beaufort. So I didn't realize the origin of the name of the scale. So a lot of times in science, the person who started it, or the person who founded or was the first one to start using it, is often what it's named after. And so I learned that with you today. So I look forward to hearing more about your experiments as well. Have a great day.